like the times that we did the PowerPoints together with these videos that we are doing the Excel solver together, feel free to pause video at any point to catch up or check the things we have discussed before. So I continue with constraint 2. Start always with equal 1/2 times s plus 5/6 times d minus 600 with the same logic I just finished discussing in the previous video. For the third one, again, start with equal, and it is about the finishing constraint. It is 1 times s. You may ask, is it necessary to put 1 times because it has no effect? No, it is not necessary. I just want to show you every step that is necessary, and plus 2/3 times d minus 7/8. And the last one, as you can see here, inspection and packaging, we model that one. I will introduce that one to the Excel as well. 1/10 times s plus 1/4 times d minus 135. Okay, now we have done also all the constraint. The last constraint that we have is the non-negativity constraint that is related to that. It says s and d must be greater than 0. So we need to do something here that I'm going to show you soon. So now that we have our model, including decision variables, objective function, and constraint modeled in our Excel, now we can go for the solver to do the rest. So here it is the graphical user interface we use for solving our model. We have the model here. Okay, see, here we have to do some settings. Here it says set the objective function. Okay, when you want to set the objective function, where is the objective function that you have? The objective function you have is here. So just click it and you see $B$6, $B$6. Always go with clicking, it's better. Okay, is it maximizing, minimizing, or value of? It is maximizing, as you can see. So I let it like this. And other things, it asks you changing variable cells. It asks you about the decision variables. Okay, when you are here, when you want to go for decision variables values are here. So you got them? So here you are introducing decision variables to your solver, and it exactly knows because it has the address. Decision variable 1 name is S, decision variable 2 name is D. Another one is asking you to introduce the constraint. So when you want to introduce the constraint, go for add. And what are the constraints that you have? The constraint cells, they are here. You can introduce all of them. Why you can do this? Because you model them in a smart way and you make all of them the right hand side. The right hand side is this part, my friend. Okay, the right hand side is this part, but since you brought all of this right hand side to the left side, the right hand side for all of these constraints is 0. So you can put 0. That's the reason I usually recommend to process your constraint in a way that all the variables and all the right hand sides RHS are on the left, so you can figure out the right hand side easier. So you see, instead of adding constraint one by one, I collect them all, add them here, and I am telling solver that all of these constraints are equal or less than 0. And okay, so we got it here also. And after that, now we are close to the end. And here it is about the solving method. Solving method that if you check, there are several methods that when you are doing it, after you get the first answer, you can check the others. It is just getting different approaches to solve this model, and it in with simple problems, with small problems, they all give the same answers. So in our class, do not stress yourself about which method to take, because it is not the focus of our class. There are some mathematical points over there. You always can use the one that is pops up automatically, and you will get the correct answer. Another point, my friends, you remember we talked about non-negativity constraints here. Here it is the part that handle the non-negativity constraint, my friend. It says make unconstrained variables non-negative. It means S and D. So when you have everything here as this, you have now objective function set, minimizing or maximizing set, you have the decision variable set, you have the constraint set, and you set the non-negativity constraint. So everything is ready for solving the model. So when I punch the solve, I should get the answer. Okay, it says objective cell contents must be a formula. I guess I put formula. Let's check it. Okay. Here it is empty. But as far as I remember, I put it over there. Maybe I mistakenly deleted it. So we are going to put equal 10 times S plus 9 times D. Now it's a formula. You see the alert that or the error that it gave me makes completely sense, because for some reason I lost the formula that I put here. As far as I remember, yes, I put it. Okay, so solver, and now for the formula that is B6, it is okay. Let's see what will happen now. And now it asked me about the answer and the solver results. So everything, you can set it as this because we want the answer. So I click these parts and okay. Okay, now we can go and check the answer. They are the answers that we see. It says value of D is 252 and value of S is 539.9999 and things like that. But remember, my friends, I just wanted to show you that you can get professional reports from solving the problem, but the other way, it's much simpler. You see, miraculously, not miraculously, it doesn't work here. My bad. Okay, you see here, now we have the values, my friends. And it says when you solve it, it says manufacture, produce 540 standard bag and 252 deluxe bag. How much would be your profit? It would be $76.68. About this part, and you see it's a very small number. To handle that, you always can come here, format cell, number, and set it as number, and just say it, round it up until 2 decimal. So you see we have 0, minus 100, 0, and minus 18. That we will discuss the meaning of these numbers in future, but for now everything is fine. Okay, it was the complete review of Excel solver that we did with the case, with the first problem that we did together. We are going to do more problems together, and now since you are familiar with Excel solver, many of the models that we are going to do in future, we are going to quickly start solving them. And it's going to be part of our regular class because it's very important that you get handy with this easy and helpful and almost free software. So again, to wrap up this presentation, in this session, we tried to solve this model. To solve this model, as we discussed it, we needed to introduce the decision variables, objective function, and the constraints to the Excel. As this way, this design, this color are completely arbitrary, and I didn't do a good job in design because, as you see, they are not symmetric. You can do it horizontal, you can do it vertical. It's completely under your control. The reason I put color here because I just want the cells that carry value stand out among the other cells. And you remember we put the formula for objective function and the constraints, and we got one error. The error happens because it says that you have not defined objective function that I thought I had defined it, and for some reason I had deleted it maybe. And always when it gives you error, the errors could be solved easily. Usually typo could happen that with double checking, that's also avoidable. So totally, Excel solver is very easy to do, and from now on you can solve any of the models that we have done together. Good luck.